So let us take this problem and read every statement given here, that we have the current in resistive branch. So we have current in resistive branch, and in which a parallel RLC circuit action. In a parallel RLC circuit, the resistive branch current is given. That is what? IR of T. So let me take that parallel RLC circuit, this one, and even the frequency domain and time domain both. So let me take that diagram over here and see that what they are saying. This IR is given for us. How much is that IR? So out of this anything can be given. Previously I assumed voltage is given. Then I try to get everything, rest of the all parameters. But now what is given is IR. So let me write that. So IR is equal to 10 cos 1000 T minus 15 degrees. I told you that previously, whatever may be the given thing in time domain, quickly move to the frequency domain or the phasor domain as IR bar. How much is IR bar? 10 divided by root 2 at an angle of, tell me, minus 15 degrees. Clear? So if you want, you can get 10 divided by root 2, how much is, or leave as it is, we get more accurate value. This is first step what I had did. Next is, what is the current in the inductive and capacitive branches assuming these values of RLC? That means how much is IL, how much is IC. Okay. So assuming that L and C and R values are known. So first what I will do is that, just let me write whatever things are given. R is given as 12 ohms. L is given as 15 millihenry. But in frequency domain I don't want L, I want XL. So for which I will calculate XL is equal to omega L. How much is omega? See that from the given current you can get the omega, 1000. So 1000 into L is 15 milli, so into 10 power minus 3. Let us see how much we will get. This 10 power 3, 10 power 3 will
15.
get cancelled. So 15 ohms. So I got the XL means ZL is known directly. Why? Because XL at an angle 90 is what the ZL. Similarly, from the capacitor C, how much is the capacitance? 13 microfarad. So immediately let us move to get the XC. How much is XC? 1 by omega C. Capacitive reactance. So 1 by 1000 into 13 into 10 power minus 6. So how much we will get this value? Calculate and tell me. So this is, so 1 divided by 1000 into 13 into 10 power minus 6. Right? Yeah. So this is 1000 by 13, which is equal to approximately 76.923. Yeah, so 923 ohms. That means XC I got means ZC I got in direct. Okay. So what I did is that from the given information, in the given circuit I try to get every required parameter which is R, ZL, ZC. Now see that IR is known, resistance is known. Now can I get voltage across this resistance? Which is equal to V, right? Voltage across the resistance is nothing but voltage across this entire circuit only. So now what I will do is that from this given information, voltage across the resistor is equal to the total voltage. Why? Because it is a parallel circuit, which is equal to voltage is current into resistance, that is IR into resistance. So IR we know that 10 divided by root 2 at an angle of minus 15 into R is 12. So how much we will get? This is 120 by root 2. Let me keep as it is root 2. Why? Because I will tell you what is the use of that. At an angle of minus 15 degree. This is what voltage across the resistance, which is equal to total voltage. Okay, this is one of the key important calculation in getting rest of the required things. What I need? Inductive branch current and capacitive branch current. That means what I need is IL and IC. How can I get IL? Tell me. Once I know voltage across this inductor, voltage divided by ZL is what IL. But how much is voltage across L? Is what the same voltage as R is experiencing. R voltage is V. So this is parallel circuit. So resistance, inductance and capacitor all have same voltage which is equal to V, which we already got it. See here, V we know. Now what I need is the inductor current which is equal to IL bar is equal to V bar divided by ZL, which is equal to V bar is 120 by root 2 at an angle of minus 15 divided by, so ZL, how much is the ZL? ZL is JXL or XL at an angle 90. XL is 15. So can I write this as 15 at an angle 90? Then as a result, let us see how much we will get this. So 120 divided by 15 is 8. So 8 by root 2, I am keeping root 2 as it is. I will show what is the advantage of that. Then minus 15 minus 90. So how much we will get? Minus 105. Right? So amperes. Let me keep as it is. So this is what the inductive branch current. For example, if I need its corresponding time domain equivalent current instead of phasor form. Now can I convert this IL phasor into IL of t? This is what very important thing. See here, I am converting frequency domain to time domain as small case letter IL of t. How much is the magnitude? 8 by root 2. In which what is the peak value? 8 is the peak value. So I will directly write 8 into. So what is the function when we converted the phasor? Like which function we eliminated? Cos function. So now I should use the same cos, same omega. So cos 1000t. How much is the angle of this IL?
Minus 105.
So this is what the inductive current in time domain. So you should be in a position to convert phasor to time, time to phasor. Now IL work is over. Next let us move on to the IC, capacitive current. How much is IC? V by ZC, which is equal to 120 by root 2 at an angle of minus 15. So ZC is, that is, so XC at an angle minus 90, right? See here, ZC is XC at an angle minus 90. How much is XC? 76.923. 76.923 at an angle minus 90, right? Okay, so at an angle minus 90. Now simplify this. Root 2 let us keep as it is. So let me write this as 120 divided by 76.923. So how much I will get is that 1.56 by root 2. So at an angle, so how much I will be? So this will become 90 minus 15. 90 minus 15, right? Why? Because this is going to the denominator, numerator. Denominator term is coming back to the numerator. It become place. So 90 minus 15 is, so 75. Now this is what IC phasor. Now can I write IC in time domain from this? IC of t is equal to magnitude, peak magnitude is 1.56. What is the function? Cos or sine? Cos function. How much is the omega? 1000t. So plus how much is the angle here? See that angle. So 75 degree. So this is what the IC. So you can get from the phasor to time domain to phasor domain in this. You can live in the phasor domain, but if somebody asks what is the time domain current, why? Because they had given resistive branch current in time domain, they asked to find what is the inductive branch current and capacitive branch current. So in this way one can do the calculations of the required things. And if some other things also ask, so like let us say what is the total current I. So let us just as an extra work, let us find how much is the total current. So how much is the total current? Total current is equal to IR plus IL plus IC in phasor form. First let us do every calculation in phasor form. If you need, you convert back to time domain. How much is IR? IR is where somewhere it is given that 10 by root 2 at an angle minus 15. So 10 by root 2 at an angle minus 15 plus how much is IL? IL is 8 by root 2 at an angle minus 105. 8 by root 2 at an angle minus 105 plus IC 1.56 by root 2 at an angle 75. So you can take this 1 by root 2 common. So then let us put everything as 10 at an angle of minus 15 plus this is one term plus 8 at an angle of minus 105 plus 1.56 at an angle of 75. And now you add up all these phasors. You can use calculator also to add these things. And let us see how much we will get. So let me take 10 at an angle minus 15. But keep your calc in degree mode, otherwise you will get wrong. So 8 at an angle minus 105 minus 105 plus 1.56 at an angle 75. Let us compare your answer and with my answer. So how much I got is, let me see that, 11.89 at an angle of minus 47.78 divided by root 2. This is what I bar. Now you can find, so in time domain, what will be the current? Total current I of t? Tell me. 11.89 cos 1000 t minus 47.78 degree. This is in time domain. Now if you want the power factor also, you can do that. Why? Because see that we know the total voltage and total current. Total voltage is this much and total current is this I. Now I can say the PF angle is equal to voltage angle theta V minus current angle theta I. How much is the voltage angle? Check it. V bar voltage angle is minus 15. So minus 15 and I bar angle is minus 47.78. So minus minus plus. So how much is this? So 47.78 minus 15. Right? So how much I am getting is 32.78. This is what power factor angle, which is usually theta. Generalized symbolic representation is theta. If you need the power factor, cos of this angle, which is equal to cos 32.78. As because angle is positive, so this is lagging nature. So how much we will get? Cos of this is 0.84 lagging. If you get the theta positive, that is lagging nature. If you will get theta negative, that is leading nature. So in this way you can calculate some of the other parameters also. So which is simple, but you should be very careful in dealing the phasor domain. Everything I deal, all calculation, algebraic calculations in phasor domain. If required, I will convert back to the time domain. Clear? So okay, thank you.